Welcome back to my channel. In previous video, we have seen working of a Zener diode as a voltage regulator. And this video is dedicated to complete analysis of Zener diode based voltage regulator. Now there can be two cases in voltage regulator circuit and we will analyze both cases one by one with examples. So please watch this video completely and thoroughly and do not forget to subscribe the channel for more contents. Now let's discuss the first case. In the first case, input voltage is fixed and load resistance is varying. Before starting the analysis, we should note two important points. The first one is the maximum current in Zener diode is limited by IZM and maximum power dissipation is limited by PZM. Both values are fixed and specified by the manufacturer in the data sheet of the Zener diode. Now let's focus on the circuit. It is obvious from this circuit that two small load resistance will result in a load voltage less than the Zener voltage, which will make Zener diode turn off. And now let's find this minimum load resistance. For this, using equation 1, that is VL is equals to VZ, which is the product of load resistance with VI upon R plus RL. This is our equation 1. From this, we will find minimum load resistance. And it is given by, so this is our equation 2. Now this RL minimum results in a maximum load current. So what will be it? VL upon RL minimum, or we can write VZ upon RL minimum. So this is our equation 3. Once the diode is on, voltage across the resistance, that is VR, remains fixed because this VR is equals to VI minus of VZ, which is equation 4. And from this we can find out the current passing through this resistance is VR upon R. Also the IZ, that is the current in Zener diode, is given by IR minus of IL maximum. This Zener current is limited by IZM. So IL minimum value is given by IR minus of IZM. And if this is a minimum load current, then the maximum load resistance is simply VZ upon IL minimum. In this way, you can find the optimal range of load resistance and the load current. Now let's solve a numerical based on it. For this resistance and input voltage, the VZ is given, IZM is also specified. Find the range of load resistance and the load current. To determine the load resistance that will turn on the Zener diode, the VL is equals to VZ, that is 10 volt. And using this, putting the values, it is 250 ohm. And IL maximum is, and it will be 40 milliampere. Now the voltage across the resistance, VR is, which is 40 volt. Using this, current through the resistance is 40 milliampere. Now the minimum load current is given by, this is very simple. Now RL maximum, it is 1.25 kilo ohm. So the range of load resistance is from 250 ohm to 1.25 kilo ohm. Second part is to find the maximum wattage rating, that is PZM. And it is the product of VZ and IZM. Now the second case is, in the second case, the load resistance is fixed and input voltage is varying. So we need to find the range of input voltage using the same concepts and steps as in the case 1. The input voltage must be sufficiently large to turn on the Zener diode. And this input voltage we will find out from again the first equation. And from this, the VI minimum to turn on the Zener diode is given by product of R plus RL VZ upon RL, equation 9. Next step is to find the maximum limit of this input voltage. If the input voltage is increasing, then it will increase the current through this resistance. Therefore, VI maximum is given by VR maximum plus VZ, where this VR maximum is given by equation 11. Since the load current is fixed, so this IR maximum is equals to the sum of IZM plus IL. So from equations 10, 11 and 12, we can conclude that VI maximum is given by equation 13. After the analysis, let's solve a numerical based on it. For this resistance and load resistance value, the VZ is given, IZM is given. We need to find the range of input voltage. So VI minimum is, on substituting the values, it will come out to be 23.67 volt. And for upper range of input voltage, first we need to find the IR maximum, which is given by IZM plus IL. Putting the values, and IR maximum is 76.67 milliampere. Using this, the maximum input voltage is 36.867 volt. So this is all about the working of a Zener diode as a voltage regulator. I hope you like this video, so please subscribe my channel and share it. If you have any queries regarding this topic or any other topic of analog electronic circuit, you can write me in the comment section or you can mail me. My mail ID is given in the description of the video. Thank you so much and have a nice day.